Hello friends, welcome to our YouTube channel. In this session, we will focus on the procedure and the list of documents required for the dish approval. As this is a part of any new plant setup or new greenfield project setup or capacity creation for the manufacturing of any of the chemical, and this is the basic steps from its the project. It is the part of end-to-end project management cycle. Basically, as you know, there are several licenses and the legal formalities, legal permissions required for the setup of new plants, chemical or whether it is a pharmaceutical, oil and gas, whatever it may be. We have to follow some the regulations as per the legal departments. Okay, basically this is the Directorate of the Industrial Safety and Health, and they provides the approval for new plant startup across the India. There are state-wise different bodies which called this, and to that we'll need to apply on the site government website through the Google. Then there are several different uh, type of approvals required, like for creation of new capacity we required the water and electricity. For this we need to submit the application for the uh, GEB or the MSEB. That is the different board according to the state wise. Okay, whether it is in Maharashtra, then you need to apply for the electrical connection, like power for the facility setup or the creation. Okay, then water for the construction purpose. These are the basic requirements at the initial stage. Then you need to go for the dish. There are several steps. First is to consent. We require to establish a new facility. This is at the initial stage, and after that, before the commissioning of the plant, we need the consent to operate. These both are the consent which we received basically from the dish body. Okay, so to get that consent, we need to apply on the link with the building plan approval before the construction, and then apply for the then need to apply for the factory licenses. Okay, before startup of the actual production. And this process involves the submission of the multiple documents which I have mentioned here in this Excel sheet, like MSDS, then the Annexure 4, Annexure 5, Annexure 6, then Building Stability Certificate. Okay, certificate for building from the architecture, then the hazardous chemical detail, list of raw materials and the finished good products, then the PFD, that's basically a process flow diagram which we need to submit along with the short process description. Okay, then we have to upload the plant layout, basic plant layout, then the hazardous zone classification layout, evacuation plan, then the firefighting network design details. Okay, so and to go for the license, we need the MSCB or GPCB, MPCB or GPCB consent with the NOC, no objection certificates, fire load calculation which covers in the firefighting network design, and along with its design details. Once we have upload all the document, dish will review the application and the plan. If they have any queries, they will get back to us through written communication, and we have to resolve that with the visiting the dish office, or if, once they give clearance, if there is no any MCs, we got the approval letter. Okay. And basically, as you know, how you maybe get a question like how long does it takes for the approval or the letter to get for the startup. Okay, the basically that plan can take up to 45 to 50 days, and once the all documents clear, the plan approved by the dish authority, and the letter will be sent us or uploaded through the government site. Then we have to apply for the factory license. Okay, for this license we need to follow the procedure which is mentioned, standard procedure you will get on the Google or the dish or the you can simply search it like factory license application. Okay, you need to apply for the fill the form number 2 and 3. Then we need to pay the fees whatever actually there is a fee for the uh, application or the detail of the firm or constitution for which organization we need the permission on behalf of, like whatever it may be, that's pharmaceutical industry or whatever chemical FMCG whatever industry, we need to share the details on the their company letterhead. Okay, and basically this the primary objective is to ensure the safety, health, and welfare of the workers as well as the environment in the factories. Okay, so we will look one by one. As you are a chemical engineer, or it's any of the MSc chemist or the mechanical engineer, whosoever is the doing the job of project manager, they have to comply or they have to get the all the documents for the approval purpose or for the registration purpose through the T's to get the license. Okay, as you know, MSDS is the material safety data sheet. You know there are several sections, and there is a standard material safety data sheet for the each individual chemicals. So I'll just show you one of the chemical data sheet so you will get some idea. You can simply get it from the Google also. I just have one already downloaded safety datasheet of the DMF, dimethyl formamide. Basically, MSDS covers the product identification, its chemical structural formula, its gas number. Basically, any of chemical has unique gas number. Okay, so simply by entering that gas number, you will get the all details about that chemical, its hazard identification, first aid measure, firefighting networks, NFPA ratings, what to do, what not to do, how to handle. Okay, all these are the sections which covers in the MSDS. Okay, I'll not spend much more time on here. Basically, we need that physical and chemical properties for the calculation purpose, like boiling point, then the density, and all these things are required while the designing. So there is another section, stability and reactivity, whether it is stable or not, and it with respect to pressure and temperature it's going to change. Then toxicological information and all these things, what will happen if person inhale or by mistakenly gone into its stomach, then what are the symptoms, what will happen, and how to mitigate that, what type of medication required or treatment required for the person, or how to contain in case of spillage. All these things are the part of MSDS. So instead of going in details, we will just look for the another document what requires here. Okay, MSDS, you know. Then we will focus on the Annexure 4. What data exactly we need to mention in the Annexure 4? So I'll just simply show you the Annexure 4. Okay, now you will get the Annexure 4 here. So basically Annexure 4 covers the chemical details, which are the like storage of hazardous chemical and its controls. What are the control or mitigation measures we have inside our factory or inside our premises? That may be in a plant, or that may be in the tank farm, or whatever it may be, the area which we have proposed for the dish approval. Okay, so here we need to share the some data. They have some standard format, like we need to submit the name of hazardous substance with its MSDS and CAS number. Then capacity, what actually the capacity of maximum of that tank or the equipment, and the actual we are using, that means the gross versus total. Okay, then the tag number of equipments and its location we need to specify in the storage and hazard control. Then we have to mention the operating parameters like operating pressure, operating temperature, whether it is going to operate at the normal room temperature, or the any vacuum application is there, or any pressure application is there. Okay, then we need to mention the critical. Okay, LEL means the, as you know, lower explosive limit. Then UEL means the upper explosive limit. uh, TLV is the threshold limit value. Then the boiling point. Okay, we need to mention that into this storage hazard and control, which is a part of Annexure 4. We need to mention all these details here. Then we have to mention the is its NFPA ratings, or someone it can call at NFPA diamonds, that represents the health, flammability, reactivity, and the specific hazard, if any, whether that's related to the stability. Okay, we need to mention that rating, whatever it may be, as per the chemical or the material which we are going to store or use inside the plant. Then we need to mention the type of hazard, whether that material is the flammable, whether that is corrosive or carcinogenic, what will happen that material is going to spill, whether that can catch a fire. Okay, all that we need to mention in the type of hazard. Okay, then we have to provide the control and mitigation measures against the type of hazards, whatever may be the type of hazards. We have to share the details to the dish authority through the Annexure 4, whatever it may be, the control measures and the mitigation measures. Then we need to provide the details of the responsible person, his name, his designation, and his contact details, so that in case of any emergency or anything, he is the responsible person, or he is the one point contact person. Okay, so I hope you got some clarity about the Annexure 4. So I'll just explain some chemical data which we are using one of the projects. We have name of the substance toluene, then its MSDS. You can simply get it. The CAS number of the toluene is 108-83-3. Okay, and we have the capacity of 20 kl tank, but that's the uh, based on the occupancy. We basically use 80 to 85% occupancy for the, as per the standard design practices throughout the plant. Okay, for storage we have 20 kl capacity of tank and it have gross of 22 kl. Okay, and operating 20 kl. Then its tag number we need to provide. Here I have tag number of T401. The tagging philosophy varies company to company or organization to organizations, so you can simply write down as per the whatever the tag number philosophy you are following in your existing organization for which you are going to apply for the license or the dish approval. Okay, then its location, whether that tank is located in a tank farm. If it's the reactor, then it's located inside the building, or whatever it may be its location, first floor, second floor, likewise. Or you can mention in the meters also, 5 meter, 8 meter, 10 meter, 20 meter. It's completely depends upon the philosophy, which philosophy you are going to follow in your design guidelines or the organization's design standards. Okay, then you have to mention here we have 50 to 100 millibar gauge of N2 blanketing cycle, because toluene is the flammable material. It comes under the solvent category, and we have to provide, or we have to avoid the its contact with the atmosphere. So in these cases we provide the nitrogen inertization. Okay, and here into blanketing is done through the 15 to 100 mbar G. That's through the you can call it at the split case PID control loop, and it's stored in the tank form. It's in the ambient room temperature or the atmospheric temperature, whatever it may be, based on the seasonal. Okay, then its LEL value is 1% on volume basis, and its UEL is 7.8% on volume basis. Its boiling point is 110 degrees Celsius. Its TLV and flash point data I don't have, so I have not mentioned here, but you can mention as per the whatever the data you have available with you, as per the chemical nature of chemical or type of chemicals. Then its health diamond indicates the rating of 2. Flammability indicates 3, means it's highly flammable. Then the reactivity indicates 0, and the stability data we don't have, that looks like a stable. Okay, in the pure stage. Then next is the type of hazard. What type of hazard arises from the toluene? Okay, from the toluene it's flammable. Then flammability, or the leakage or spillage or overflow of that tank. Okay, these are the common hazards we have to mention. Okay, in case of you are unloading from the tanker to the tank, there may be a chances of spillage, or there may be a chances of overflow, spillage through the flange joint, leakage through that same also. Or if there is no into inertization, then there may be a chances of the flammability. Okay, it can catch a fire if that follows within a range of LEL and UEL. Okay, then we need to mention the control and the mitigation measure. What are the control measures? As I have mentioned here, it is flammable. Okay, then we need to provide the, we have provided the nitrogen inertization or nitrogen blanketing in the tank, and the vent of that tank is connected to the common vent header of the plants, and that common vent header is gone to the open to atmosphere through the flame arrestor, because we need to install the flame arrestor, as there is some component mixture of the flammable material. Okay, then we need to provide the overflow protection, like receiving wall. We can close receiving wall based on the high level sensation against the level transmitter or the level switch. Then in terms of mitigation, we have safety shower and the spillage control kits provided in that particular tank farm area. If something happens like this spillage or the overflow, we need to contain that to avoid the exposure to the human or the environmental exposure. Okay, then we have selected the tank pump and its associated accessories are compatible, because we need to select the material of the tank, pump, piping, which according to the chemical compatibility of that material with the chemical which we are going to store into that. Okay. Then we have bottom actuated wall operated from the DCS. In case of any leakage through the bottom line or flange joint, we can simply close the bottom wall from the DCS without visiting that tank form area. Okay. Then we have installed a safety wall in the tank form line to like we are transferring, there may be a chances of hydraulic lock or thermal expansion due to hydraulic lock. In this case we have safety wall designed for this case and installed on the line. Okay, so likewise we have same for the another chemicals also. Then we need to share the data to the dish authority in such a format. Okay, and for the final product also, as I have to maintain some confidentiality, so I have not mentioned here the product data. Actually just I have simply put it down some uh, control measures and the type of hazards which arises from the product also for your reference. Okay, it doesn't exactly match with the product which I have mentioned. Okay, then we need to share the data of the Annexure 6. Annexure 6 covers the process and the vessel hazards and its control. Okay, then it is similarly like the Annexure 4. We need to mention the plant or details, then name of hazardous process. Basically, Annexure 4 focuses on the each individual chemicals or the intermediates, and Annexure 6 focus on the steps of the manufacturing. There are several number of steps or the unit operations in the manufacturing or production of any of the chemicals from raw materials there, that involves certain number of stages or chemical reactions or unit operations. So Annexure 6 focuses on that operations and its operating conditions, and we need to provide the mitigation or control measures against it. So basically, I have here the initial solution one. Basically, this is the two solution preparation that goes to another intermediate one passes to the intermediate two with the some another addition of the chemicals. So I have not mentioned the details here, so you can simply, you will get just idea about what documents need to share with the dish and what are the things we have to mention into that. Okay, that's the main purpose of this video session. So we have to mention the chemical details and its quantity. Then we need to mention the equipment details or tag number and its location, whether it is located or it's foot mounted or the rested on the lug or whatever it may be. Then we need to mention the operating parameters like pressure, temperature, whether it is going to operate on the higher pressure, higher temperature, whether it is reaction is the exothermic, endothermic, that needs to mention in this column type of hazards, because exothermic reactions are called like a critical reactions, or the toxic gas release or fire explosion like this. So we have to mention the type of hazards here. For this particular step one we have toxicity, so we have control measures I have mentioned here, like the hazardous material charging. As this is the step, these steps involves the preparation of the solution, means we have to add some solid toxic solids into the water, so that charging is done by manually but in the presence of supervision. Okay, and this charging of that material takes place under the closed room, as this is the toxic chemical or toxic solids that releases the gases which are hazardous, like chlorides or the chlorine or the whatever. gases are toxic for us, like this. So we have connected the vent of that system to the scrubber. In case of any gas generation is there, that can be scrubbed through the caustic solution. Then there is a overflow protection with the high level interlocks. In similar way, we need to mention the whether it is a plant manager responsible for this or the plant head, site head, whatever it may be. We need to mention his name, designation, and his contact details. Then similarly, we have to mention the steps, whatever steps you are going to follow throughout the manufacturing of that chemical. You need to mention that. Okay, here I have two chemical intermediates. Then we are going to transfer that intermediate to the filtration. The filtration operation happens. Then some solid are going to filtrate. In some cases, there may be that solid cake is the uh, hazardous for the like hazardous for the human exposure. Then we need to pack through that to the closed packing system. Likewise, control measures we need to provide. Okay. Then intermediate 2 is the high pressure reaction or the somewhat the pressure reaction. Then we need to mention according to the whatever it may be the pressure 80 millibar gauge to the 4 millibar or the 4 bar gauge. I mistakenly write it. Then the reaction temperature is 45 to 62. As this is the thermal decomposition, you will get the thermal decomposition temperature from the DSC, detail screening calorimetry, or the reaction calorimetry data. That may be a short term or long term. If you have conducted that for the long term, then you can simply put it 10 degrees Celsius delta in the set decomposition temperature and the set point for the operational stoppage or the interlocks. Okay, so in as this is the thermal decomposition, that means this is the exothermic reaction. Then we have to mention some high temperature interlocks, then overflow protection. Also we need to put interlock on the charging of that material which causes the exothermicity generation. We need to stop that in case of low agitation. Also we need to add such a component in a controlled manner. Okay, so these are the basic control measures we need to provide to the dish, so that they will get the brief idea about we are going to install or create a safe facility for the human as well as the environment. Then we can share the details of safety wall with rupture disc for overflow or pressure protection and all these things. Okay, so hope you got somewhat clarity about the MSDS Annexure 4, Annexure 6. Then we need to share the hazardous chemical details. Okay, this is the same format like the others. I'll just explain you so that you will get. We need to share the details of hazardous chemical in such a format, like hazardous chemical name, then what is the concentration actually we are using, whether it is 100% pure substance or 50%, its gas number, then the total number of tanks or the receivers in which we are going to store the material, and its unit. Okay, and the total quantity of whatever the material we are going to store, then its capacity of largest storage tank, then nature of material, whether that is in solid, liquid, or gas form, or whether it is in a solid suspension in a liquid. Okay, these in this template we need to share the hazardous chemical storage details to the dish, so that they will get the complete idea about the what are the chemicals we are using or what are the hazards and its quantity, how to mitigate that. Okay, then the next point is that uh, PFD, list of raw materials and finished products. So we'll just simply need to share the list of raw materials and the finished product in such a template. You can simply share the list of raw materials, toluene, acetic acid, xylene, XYZ, whatever may be the any limiting reagent or whatever the component you can share, like this caustic soda and the catalyst, and you can mention the finished product along with the byproducts or whatever it may be. You need to mention in this format and share to the upload to on the portal. Okay, then next topic is that the PFD. Okay, so in PFD, I'll just as you are a chemical engineer or the mechanical engineer, you simply know what actually data covers in the process flow diagram. Is simply a blocks, what are the reactor and unit operations, what are the quantity of materials we are going to charge in each stage, or what are the byproducts or ML generation. I'll just simply show you one of the PFD simply for your reference. This is the I have just taken from the Google for the reference. This is the polybutylene. These are the flow diagrams. You can call it as a flow diagram. How actually it looks like on from which steps to it follows. How what are the equipments are used. Major parts like equipments, tanks, pumps, then filtration units, crystallization. All these things are mentioned in this the process flow diagram along with the input stream details, or you can simply call it as with the material balance details. Okay, then we need to share the process short description. What are the actually processes in the step one. We charge XYZ material, then we maintain that much of temperature and pressure, or whether it is an opera, blah 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 blah. Okay, so you have to mention in a short so that they'll get the idea about the what is the actual process. Then we need to share the effluent generation and its disposal details. What type of effluent is generated, whether it is that is solid or liquid gas, if the effluent generation is done, how we are going to treat. And nowadays the industries or the government authorities or bodies are focusing morely on the zero liquid discharge plants. Okay, in case of liquid, we need to treat that liquid into the effluent treatment plant or water treatment plant, wastewater treatment plant. Whether if that is in the form of gas, we need to incinerate that from the incineration plant. And if there is some solid or the cake formation or cake byproducts or the effluent generation due to our chemical process reactions, then we need to provide the disposal details, whether that is going to landfilling or that can be sold to the any other industry for as a raw material. That details we need to share with the dish. Then we need to provide the plant layout. Actually, what are the datas or basically plant layout. Right now I don't have any plant layout details, so I'll just explain you with these files. Like we need to mention this is the tank form area, type of tanks with the capacity, then the plant area, then admin building. And these likewise these utility, expansion, plant utility, store, fire station, canteen, emergency water. Then we need to share the green belt area. All these details we need to provide in the plant layout. Basically, there are several some guidelines for the plant layouts. Like we need to provide the peripheral roads of the 6 meter around the plants, so that in case of any emergency or any fire or the any situation arises, the fire tender or the anything can smoothly run across the plants. Okay, then we need to mention the standard design guidelines, like the gap between the two equipments is 1.2 to 1.5 meters. Then we do provides the ladder as per the design guidelines, and that can be covered. I'll cover in the next session as we have less time or a little bit time in this focus on this. Then we need to provide the hazardous zone classification layout. I'll separately explain you the what is the actually zone classification, how it's classified, what are the things are the basic criteria to define the zones, and all these things. Okay, then we need to share the evacuation plan, firefighting networks, and the structural stability certificate for the building, whichever it may be, RCC building or the structural steel building. We need to provide the certificate which we got from the architectural designer. Okay, we need to basically tentatively at least we need to provide that much of the documents to the that needs to be uploaded on the government portal on the dish websites, so they can review and get back to us with the queries whatever they have doubts, and usually they have some doubts and they ask, and we need to provide the proper solution or proper we need to satisfy their questions with the proper justification. Okay, hope you got the some of idea about the how uh, to proceed or how to approach for the dish prior to startup, or do consent to establish or consent to operate. Okay, and what are the documents I have simply explained here. But still, if you have any queries, you can drop me a message in a comment section chat box, or you can simply write down me a mail on the mail ID which we have provided in the channel descriptions. And be with us for such a interesting project management videos or the process engineering related videos. So thank you for now. Bye bye.